Hello everyone, welcome back. Today we are going to learn about preemptive priority scheduling in operating system. Okay, so basically this algorithm is important because it decides which process gets the CPU first based on priority. Okay, so it can preempt running processes like if something more important comes along. Okay. See, definition. Preemptive priority scheduling is a CPU scheduling algorithm in which each process is assigned a priority. So the CPU always executes the process with the highest priority. Okay. If a new process arrives with higher priority than the currently running process, the CPU preempts the running process and executes the new one. And this is a preemptive algorithm, so processes can be interrupted anytime based on priority. See, so what is preemptive priority scheduling? So in this method each process has a priority number. Okay, priority number. Okay, so the CPU always works on the process with the highest priority. Okay, so if a new process comes in with a higher priority than the one currently running, okay, so the CPU will pause the running process and give control to the new more important like process. Okay, so this is why it's called a preemptive algorithm. Okay, so because the CPU can interrupt a process anytime based on priority. Okay, now see key features. Priority assignment. Each process has a priority number. Then preemption. Higher priority processes can interrupt lower priority processes. Then ready queue. Processes are arranged based on priority. Then starvation. Low priority process may wait indefinitely, solved by agile, gradually increasing priority. See, so basically here are few important things to remember. Okay, so basically every process has a priority. Okay, every process has a priority, so higher numbers can mean like higher priority or lower depending on the system. Okay, but in our example higher number means higher priority. Okay, then it's like preemptive, so process can be stopped midway. Okay, it's preemptive, so process can be stopped midway. Then ready queue, it's like the CPU looks at the ready queue and always picks the highest priority process. Okay, then starvation. See, sometimes low priority process may wait a long time. Okay, which is called starvation. Sometimes low priority processes may wait a long time, so which is called starvation. So this can be solved using agile, where waiting processes gradually get higher priority. Okay, then example. See, so let's take a simple example. Suppose we have four processes P1, P2, P3 and P4. So their details are like here. P1 burst time 10, priority 2, arrival 0. Then P2, then P2, burst time 1, priority 1, arrival 1. Then P3, burst time is 2, priority 3, arrival 2. Then P4, burst time is 1, priority 4 and arrival 3. Okay, so basically we are assuming higher number equal to higher priority. Okay, See, so here is how the CPU executes. Okay, so time 0, first is time 0. Here is only P1 is available, so CPU starts P1. Okay, then time 1. Okay, so here is P2 arrives, but priority is P1. Okay, cause 1 is less than 2. Okay, then see, time 2. So here is P3 arrives with priority 3. So higher than P1 means CPU falls P1 and runs P3. Okay, then time 3. So here is P4 arrives with priority 4. Okay, so highest priority means CPU falls P3 and runs P4. Okay, then time 4. Here is P4 finishes. Okay, then next highest priority in queue is P3. So CPU resumes P3. Okay, and now time 6. Okay, so P3 finishes. So P1 is next. So CPU resumes P1. Okay, then time 14. So basically P1 finishes, so only P2 is remaining, so CPU runs P2. Okay, then time 15. Okay, so basically P2 finishes, so all processes are done. Okay, so see, if we draw a timeline, it look like this. See, look like this. Okay, like P1, then P3, then P4, then P1, then P2. Okay, so notice, see how the CPU always gives priority to the highest priority process. Okay, it's like P1 is highest priority. Okay, so and lower priority process have to wait, means P2 is lowest priority. Okay, but like eventually get their turn in the end. Okay, now see advantages. So here is advantages. One is like important processes run quickly. Okay, high priority processes are executed immediately, suitable for real time and critical systems. See, so advantages is like works well for real time systems where certain task must be done immediately. Okay, and ensures CPU is always working on the most critical task. Okay, and disadvantages: low priority process may have more complex than simple scheduling algorithms, requires priority assignment which may not always be simple. Now see, so basically low priority process may wait a long time, starvation. Okay, slightly more complex than simple algorithms like FCFS. Okay, and assigning priorities may not always be straightforward. Okay, so summary is preemptive priority scheduling is a preemptive priority based CPU scheduling algorithm It ensures that high priority processes get CPU first and lower priority process wait, but care must be taken to avoid starvation. See, so basically preemptive priority scheduling is all about giving the CPU to the most important process first. Most important process first. Okay, and it can preempt running processes whenever needed. Okay, so it's very useful in systems where some tasks are more critical than others. Okay, so like, but we have to be careful to avoid starvation for low priority processes. Okay, so basically this is like an important CPU scheduling technique used in systems. Okay, so where some processes are more critical than others. Okay, so in preemptive priority scheduling, like every process is assigned a priority. Okay, so the CPU always selects the process with the highest priority to execute first. Okay, so if a new process arrives that has a higher priority than the process currently running, so the CPU preempts the running process. Okay, so that means like the lower priority process is temporarily false and the higher priority process gets the CPU immediately. Okay, so this is preemptive nature. Okay, ensures that the most important tasks get executed first. Okay, so which is especially useful in real time and interactive systems. Okay, so like all processes waiting for CPU time are kept in a ready queue, unlike like simple algorithms like first come first serve. But here the CPU doesn't just go in order of arrival. Okay, so instead it looks at the priority of each process in the ready queue and always selects the one with the highest priority. Okay, so if multiple processes have the same priority, most systems use first come first serve among them. Okay, so but the main point is priority rules over arrival time. Okay, so see why it is matters. Preemption is the heart of this scheduling. Okay, so think of it like a traffic signal for processes. Normally a process is running peacefully on the CPU. Okay, but the moment a more important process arrives, the system follows the current one and lets the urgent task go first. Okay, so basically this ensures that critical operations don't have to wait, which is why this method is often used in real time systems like medical devices and like air traffic control or like stock trading applications where delays can be costly. Okay, so one challenge with preemptive priority scheduling is starvation. Okay, so basically starvation happens when low priority processes keep getting postponed because like higher priority process keep arriving. Okay, so like see, imagine a tiny process waiting forever because bigger more important process keep cutting in line. Okay, so to solve these systems use a technique called agile. Okay, so agile gradually increases the priority of waiting processes, ensuring they eventually get CPU time. So this balances fairness with priority based execution. Okay, and the preemptive priority scheduling advantages are like so powerful, like critical tasks are executed quickly and high priority processes don't wait unnecessarily. So, and the second one is A second one advantage is efficient for real-time systems. So the systems can respond immediately to important events. And the third one is dynamic decision making. So basically the CPU can switches task whenever needed based on priority. So it's a system that's both flexible and responsive. Okay. And the disadvantage is, uh, first one is starvation risk. Okay. So low priority process may wait too long without agile. And the second one is more like complex. Managing priorities, preemption, and context switching is more complicated than simpler scheduling algorithms. And third one is like, requires careful priority assignment. Okay, so deciding which process are more important isn't always straightforward and can affect systems performance. Okay, so basically preemptive priority scheduling is a preemptive priority driven CPU scheduling algorithm. Okay, so basically it ensures that critical tasks get CPU time first while lower priority processes wait. Okay, so it's widely used in a real time and interactive systems, but we need to be careful about starvation and like make sure the system is fair to all processes. So understanding this algorithm gives you a clear picture of how modern operating system handle multiple tasks efficiently. Okay, so that's all for today's deep dive explanation of primitive priority scheduling. Okay, if you found this helpful, don't forget to like, comment, and subscribe for more operating system tutorials. Okay, thank you.